Hey you folks, Cool18 here, and welcome to another Unity 3D tutorial on how to make a multiplayer first-person shooter. We actually haven't been looking at the multiplayer component of this in the last two episodes because we've been working on implementing a very simple example of a bot. We've got a bot that can follow along with different waypoints and can locate targets and turn to face the target and more or less aim at the target, but it doesn't actually shoot yet. And before we can do that, we have to go ahead and sort of split out this player shooting behavior just a little bit here. I think we looked at it very briefly in the last video, but the player shooting script, basically, 99% of the script has nothing to do with the actual player itself. Instead, it's got a little bit in the update here. We check to see if the fire button is being held down, and if it is being held down, we call fire. Now, in fire itself, it does fire a bullet, and the direction of the bullet is determined by the camera attached to this character. So that's really the only couple of things that are player specific. For this to work for our bot, we need the sort of update function to make some sort of decision as to whether we should fire. And then the aiming will be done slightly differently because we're not going to be shooting a ray out from the camera. Instead, we know exactly where the bot wants to shoot. So we'll make basically a ray that comes out of that intended vector, but we'll add a little bit of noise to represent the fact that bots are not terribly accurate. So yeah, we'll take a look at that. So I think we can probably get started. So what I'm going to do is I'm going to try to chop this up a little bit. So there's going to be this player shooting script, but I think maybe we'll have a character shooting script. I'm wondering, we might just be able to add it to network character. Actually, I think that's what we're going to do. The network character script is a script that manages, say, all characters, whether they're bots or human beings, get processed in here. So what I think we're going to do is make some sort of like shooting script in here. We'll do public void fire weapon, and then we'll take a vector 3 that is the direction of the shot that we want to fire in. Now this function will more or less, I'm going to grab the entire fire function over here. We're going to grab all of this and stick it inside of here. Now we're going to see a lot of red bits because there's references to things that we don't quite have here. The other thing we're going to do is we're going to take out, or not take out, we're going to change this ray cast that we're doing. Instead of firing from the camera's position and the camera's direction, we're going to use the vector's direction. And we're going to fire from, I don't know exactly where we're going to fire from. Maybe we'll have to ask for position as well. I guess so. We'll play it safe. We'll ask for a, maybe we'll call it origin, and we'll do something like that. And then over in our player shooting script, we can basically take all of this out. Our fire, instead of firing this way, what we're going to do is we're going to call our, I don't think we have a reference to our network character. No. So let's go and take a look at what our player movement script looks like. So it grabs a reference to network character, so we're going to borrow that. And then in the start, we're going to copy the code here where we actually grab our component, like so. So now our player shooting script will also have a copy of our network character component. So in our update, when we hit the fire button, instead of calling fire, what we're going to do is call netcar.fireWeapon, and we're going to feed it in the same information here. We're going to say we want to fire from the camera's position in the camera's forward direction. And then what we can do is we can actually just get rid of this fire function completely. We don't need this to be here. The do gun FX function, this is something else that can be moved to the network character. Like so. You can see that there's still some references missing. An FX manager, we're going to go ahead and pull that out of our player shooting. We're going to move that into network character. So let's go back up to the top. Grab a reference to our FX manager there and there. So the FX manager is responsible for making the visual effects of the game happen. Technically, cache components is supposed to be over here. Yeah, okay, we'll put this all in cache components, like so. So now, there are fewer missing references in network character. Still needs weapon data and cooldown. So let's go ahead and take a look at that. That's pretty straightforward, I think, as well. Obviously, we're going to grab that line. put it there. And then where do we actually grab our weapon data? Oh, I think it happens automatically in shooting. In fire weapon, if we don't have weapon data, we find weapon data at that point. This also will work properly when we finally get to weapon swapping, which is going to happen very soon. The next episode is going to be about picking up health pickups, and then we're going to go from there into picking up extra weapons and then weapon swapping and that sort of jazz. And then the only thing we're missing at this point, I think, is the cooldown variable, so we're going to go ahead and grab a copy of that as well. Right over here, so we can call this shooting stuff. And in player shooting, in our update routine, we decrease the cooldown, so we're going to go ahead and do that as well. So we have a fixed update. We can probably just do it in the fixed update. I'd rather actually do it in update, since when we start a shot is based on we process the shooting in an update, so we're going to make sure our cooldown is updated within an update as well. It doesn't really make a terrible amount of difference, but that'll be fine. So now, find closest hit object. I suspect that we need that in our shooting script, don't we? Yeah, find closest hit object. So most of the code, and this is what I expected, most of the code from player shooting has been completely stripped out. Now the only thing the player shooting does is verify if the player wants to shoot a gun. And that's it. Which is fine. We can work with that. No problem at all. I think that if we were to run this, I think we would be back in the situation where our scripts would work. Now, you don't have to do it this way. What we could have done instead, and it looks like we're working. Let's see if we can kill the bot. I have terrible aim. There we go. It's still doing that thing where it's not killing our character, but it's killing our camera and then starting a respawn. We're going to have to see exactly what's happening in this bot script. Maybe it's time to take a look at that, actually. We have a health component, which we're going to go ahead and take a look at. I'm pretty sure that's what's going on. When we die... all right. When we die, one of the things we do is we check to see if this object is owned by us. And then we're using that, and we're checking to see if the tag on the object is a player. And I think it's fine that the bot has a tag of player. And, you know, starting a respawn and everything for that character would be okay. Because we change the camera, we change the active camera, and then we start a respawn timer, which is not what we want. Maybe we'll use different bots, or different tags. We'll go ahead and change the tag on the bot controller to bot, just for now. So we're going to make a bot tag, and then assign the bot to the bot tag, and that'll bypass this. Else if gameObject.tag equals bot, debug.log error, warning, no bot respawn code exists. So we'll deal with that later. But now that'll get rid of that really weird behavior where killing a bot respawns our player. Okay, so yeah, I think I was saying what we could have done in player shooting is we could have changed the code in there and used the same script for both bots and players. But I think this will be a little bit better to have it segregated out. In fact, I think that what would make more sense actually is for player movement and player shooting to be the same code. And what we could just call this is player control or player controller or something like that, that handles both movement and shooting input and output by the player. And then the same thing for the bot. And maybe for the bot, what I'll do, instead of calling it bot movement, we're going to rename this. We're going to name this to bot controller. So this script is going to be responsible for all bot AI, period. So what we do is we rename it in Unity, and then we pop over here. Let me close all the tabs just to make sure we have nothing weird going on. Then in MonoDevelop, it's very important. Right now, the game will not work. And the reason is that bot controller and bot movement, the file name needs to match the class name. So we're going to rename this to bot controller. This script controls all aspect of bot AI, including movement and shooting. There we go. And I think that that is a much more reasonable way of organizing it. I think very much we'd probably want to do the same thing with the player, but we'll go ahead and leave them separated out at this point. Like, we could literally just delete the player shooting script completely. Actually, we really could, couldn't we? You know what? Let's stop talking about it. Let's just do it. We're going to remove the player shooting script. It doesn't do anything anymore. Instead, the player movement script, we're going to rename it to player controller. We're going to go ahead and open that. We're going to do the same thing where we rename this to player controller. And we're going to grab this code in our update. We're going to copy this, go down to our update. So first what we do is we check all our inputs and outputs. We adjust our movement. And then before we, right after we adjust our aim angle, let's go ahead and check to see if we want to shoot. And then we can actually just get rid of this player shooting component completely. It doesn't need to exist anymore. So I will get rid of player shooting by selecting it, deleting it. And if we go to our player controller, it'll actually complain about the fact that it's got a missing component over here. So we'll just go ahead and remove that component. And again, if I hit play, everything should be not quite hunky-dory. Object reference not set. There's no player movement script. There's no player shooting script. Let's go ahead and remove that and just call it player controller. If we'd been using the version with generics where you use the angle brackets over here, we would have been told at compile time that there was an error as opposed to runtime, which is why I tend to prefer it. We've got another object reference not set. Because the bot movement as well needs to be updated. This is bot controller. And now it's like we've trimmed down our scripts completely and we've unified a lot of things, which is nice. There we go. We can shoot again. And let's see if we can kill the bot. It, of course, won't respawn. Oh, I'm so bad at this. There we go. Warning, no bot respawn code exists. Excellent. That's exactly what we're looking for. Okay, and you can see this code here. This is I never did this on air, but it was just some testing code to spawn a bot right at the beginning of the game so that we could test a little bit easier. If you do download my project file, you can find this code here, and there's a little bit more testing code right at the top, right over here. So if you download my version of the project, you can verify that, or you can just read it off the screen now. Okay, I'm pretty happy about that. Now what we need to do in our bot controller, we are processing our movement. I don't like the fact that we've got a single big monolithic update routine. Let's go ahead and splice this up a little bit as well. So let's make a few functions. We'll do, we'll call get or set. I don't like any of those. Maybe just update. Oh, here we go. We'll go do destination. So all this code that finds our destination is this. And then we'll call, at the start of the update, do destination. Then, here's our movement code. So, we'll go void do direction. So it's our movement, which is this. So we'll cut that out, put that there. So this is where we set our direction. Then the next code we have is facing, which partially involves finding a target. And remember this note about things being slow? We're going to go ahead and by being able to parcel this out to a function, we're going to clean things up and make things a little bit more optimal. So we'll do something like do targeting. This is where we find our target. So our target is, targeting stuff is this bit over here. So let's copy or cut this out. So this is where we find our closest target. And what we've been doing is just using this local variable of closest, which we then use for facing. Let's go ahead and save what our current target is. So we're going to have a, I don't know, some sort of transform or team member. We're using team member over here, and I think that's probably okay. Team member, my target. Explicitly set it to null because of reasons. So what we're going to do with do targeting, we're going to get to the end over here, and we'll set my target to be the closest possible target. And then in our code down here, which is now complaining that we don't have this closest, what we can use is my target, my target, my target. So this is the code required to find the targeting. Then what we're going to do is have another function called do rotation, which turns us to face what we're supposed to face, which is all of this code. And we'll also include the aim angle stuff in there. I think that's perfectly fine. Do rotation. There we go. And I'm much happier about our little update routine now. It becomes very, very clear what's happening. I'm actually going to move it up a little bit because I kind of like that sort of thing in my code where right away you can see the update at the top so you get a sense about what the logic, what the flow of all this is. So we haven't changed anything. We've just sort of restructured things so that we don't have a function that is like 50 lines long. Ideally, I like to keep my functions beneath 20 if possible because it makes them in nice, digestible little chunks. They also means that a single function fits nicely on one screen. You don't have to scroll up and down. So you can sort of load the entire thing in the RAM that is your brain and not have to page things in and out. The do targeting is a little bit long, but I'm not sure that there's a good way around that. You know, just because of the amount of sort of nested ifs that are required here. It's not my favorite. Maybe we could restructure it. And certainly if we're a little bit less verbose in things, we could probably do it. But I think it's going to be perfectly fine. The do rotation is also long because it's actually doing two different parts of the job. Rotate towards our look direction. Look direction. Right, rotate towards our look direction. Now we adjust our aim angle for animations. So it's kind of doing two things. We could potentially do the aim angle adjust as a separate function, but I think we're going to be okay. So now that we've done all this, what we're going to do is we're going to make a new function. We're going to call something like do fire. This is going to be the function that determines if we are going to fire a weapon, and we're going to pass that information to our network character script if we decide to do that. So let's go ahead and start padding this out. So this is going to be the actual bulk of today's little tutorial. I realize we're already 17 minutes in, and we haven't done the real thing yet. Let me pop back over to Unity to make sure that I've got my network character up and running. And do we currently still have some errors? Yes, name closest does not exist in the current context. Oh, that's supposed to be my target. Any others? Good. Okay. So do fire. So basically what we want to do is if my target is null, well, if we don't have a target, we're not shooting at anything. So just go ahead and return. I suppose I could trim this down by not doing that. That'd be fine in this case. So if we don't have a target, then we just butt out completely. Then we want to find out what the angle between ourselves and our target is. Now, for this purpose, I think we're going to ignore the vertical angle. We're going to assume, while we might change things so that we rotate more slowly. Right now, we're instantly snapping and rotating to face whatever our target is, which is a bit unrealistic, and we might be able to adjust that later. I'm going to assume that the up and down movement of my arm is more or less instantaneous, and that's going to be okay. What we're going to do is we're going to pad this out with sort of like awareness slowdown things. Right now, as soon as someone enters our range, we instantly target and turn towards it. What we'll do is we'll add in a little bit of a timer later, potentially at some point if bots become important, to represent some sort of mental lag in the AI. Actually, speaking of, I mentioned that this do targeting is slow because of lots of reasons. There's probably ways to optimize this particular line, for example, to be less slow, but one of the things we could do is just not do the targeting every single frame. How do we do that? Well, let's go ahead and do something like a float targeting cooldown. We'll set it to 0 to start off with. And it's very simple. First of all, do targeting. We forgot to actually call this function. That would have been bad. If targeting cooldown is less than or equal to 0, then we do the targeting. And we want to figure out some sort of delay. How frequently do we want to do this? Because we're going to reset the targeting cooldown. So maybe we want to update our targeting cooldown every half second. Every half second, we scan for a target. Already, that's going to dramatically cut down the load that this function runs, especially with lots of bots. And of course, we'll have to remember to do a targeting cooldown minus equal time dot delta time. So it actually counts down. So now we're only checking for a target every half second. Much, much, much faster, less of a load, that sort of thing. And this will also somewhat simulate a lag time in the AI noticing. Because depending on exactly when you come in range, it might take the AI a full half second to recognize that you're there. Sometimes not. This is not necessarily the ideal way of doing things, but, you know, it's there for now. All right, so if we don't have a target, we return. If we do have a target, what we're going to do is we're going to figure out the angle between us and the target. And basically, if the target is more or less in front of us, we will attempt to shoot. And that's all there is to it. We'll sort of start spraying bullets when the target is roughly in front of us. So let's go ahead and figure that out. We know where our target is. We know where we're currently facing. All right. So we are currently facing transform.forward. This is where we are facing. So let's do something like this. What we're going to do is we have vector 3. We're going to have target position is going to be equal to my target dot transform dot position. But then we're going to set the target position dot y to be equal to our own position dot y. That way we ignore the up and downness of it, just for the sake of determining if we are going to shoot at all. Ignore vertical height for determining if we should shoot. So we're going to make sure that we're on the same plane here. Then it's very simple. We can just calculate the angle between our forward position. So vector 3 dot angle will want two vectors. So the from and to, so the from is our own transform dot forward, and the to is the direction between to reach our target. So the direction towards our target is very simple. It is going to be our target position minus our own position. Whoops. That's the direction towards our target. It's the target's position minus our position. This is the direction to there. This is the direction we're facing. So we're going to get the angle difference between those two. So what we want to say is something like, if the angle formed by that is less than, I don't know, let's say 10 degrees. So we'll put this in a variable, maybe up here. Float target angle criteria equals 10 degrees. The angle at which our target needs to be for us to start spraying bullets. Very, very simple. This is not going to be a smart, sophisticated bot. So we're going to go ahead and do that. I suspect we're going to want to shrink down that angle quite a bit, but we're going to go with it for now. So we're going to change this to target angle criteria. So if we're within that, we're going to shoot. How do we shoot? We call netcar.fireWeapon, and it wants to know the origin of the bullet and the direction of the bullet. So we're going to deal with the second part first. The direction is very, very simple. We are going to shoot forward. Now, we have to remember, though, that the aim angle, the vertical angle, doesn't matter. Well, there's a few things we could do. We could actually cheat. We could literally say the direction of our shot is going to be this. This will ensure we are literally going to, especially say if we put our position in here, this will fire a bullet directly at our target, no matter what. 100%, because what we're doing here is we're feeding it a direction that is the vector, the direction between us and our target. So these bots are really going to be running aim bots, because as soon as they're within 10 degrees, they will fire a shot and the shot will go directly towards our target, which is not necessarily what we want. What we really want is sort of the shot to go straight ahead out of our bot. So our straight aheadness is sort of this transform not forward, but this transform not forward only deals with rotation around our y-axis, if you remember. If we're looking sort of straight down, our rotation of our bot only rotates around the y-axis one way or the other way. All the vertical sort of angle is basically the aim angle. So what we're actually doing is we're firing based on not this direction. Our correct direction is going to be this transform dot forward plus our aim angle. So we can do that. Vector 3, this is going to be the fire direction, which is going to start off being our forward angle over here. But then what we're going to do is we're going to rotate it downwards based on our aim angle, which we can do pretty easily. What we can do is we multiply this forward vector based on a rotation. Rotations or quaternions always have to come first. We're going to feed it in some sort of Euler angle. And it's going to be, well, what is it going to be? It's going to be a rotation around the x-axis locally. So, let's figure this out. Instead of saying transform.forward, which is our forward-facing direction in world space, we could just do something like vector3.forward, which is basically the same thing as a vector, new vector 3, that goes 0, 0, 1. Oops. Because positive z-axis is the default local forward direction. So this is a vector that in local space, so, you know, ignoring any rotations around our character or whatever, this sort of points straight out of our head in our local coordinates. So then if we take that and we multiply that by our aim angle around the x-axis, so net character dot aim angle, if we do this, then we get a vector in our local space. Let's talk about what local space means. If I go ahead and drop in my bot, whoops, come on, bot controller in the scene, and then I zoom in on him, we can see, and let's give him a little bit of a rotation actually. Let's go ahead and just sort of turn him this way. Now, these axes that you see here are in world space or global space, which we can see over here. So the blue arrow is facing, that's the z-axis, and it's facing towards positive z in global space. But if I hit this button and switch it to local space, that's what we're talking about. Now the axes are oriented towards the local space of the character, not the world. And so the z-axis faces forward out of that character, and the x-axis is the right. So if our aim angle is sort of up and down, it's a rotation around the x-axis. So that's what we're going for right over there. Let me get rid of this bot controller. So this is fire direction in local space. If we want to make it into global space, what we say is fire direction now is equal to our transform dot transform direction, and we feed in the direction. So now what it's going to do, it's going to convert it from local space to global space based on our current transformation, our current rotation, for example. Some of these things also, for the point anyway, is based on scale, but scale won't matter in any way whatsoever here. So this should now have our fire direction. So first, get our fire direction in local space, convert to global space, and then we are going to shoot out of that. Now, most likely, this aim angle is actually not going to be quite correct. I'm going to go ahead and do a debug.log of the angle that we are shooting at so that we can see it. I suspect we might have to do a plus or minus 90 degrees or negatize this or something like that. We'll go ahead and take a look. The other thing to note is this transform.position. This transform.position is the source of the weapon fire, and right now, that's going to come out of our feet. Because if we drop our character into the game again, come on, you can do it. You can see that the origin of our character is here at our feet. Now, for our player, we are shooting, and this is very important, we are shooting out of our camera. And that's what we want, because it's the viewpoint of the player that we want the shot to actually originate from. The special effects of it come out of the gun, but the shot comes out here. So for our bot controller, what do we do for that? Well, there's a couple of different options. We don't want to come out of the feet because, well, there's all sorts of weird line of sights. Like if there's a little bump over here, then we won't actually be able to shoot players because it's going to try to go from feet to feet. The other thing to note is that our targeting of this player is based on targeting from feet to feet. None of this is right. What I'm going to go ahead and do is hard code in that we're going to want to fire about 1.5 units up, which is about chest level. So we're going to fire out of our chest level area into chest level area. The visual effect will still be coming out of the gun, but that'll be pretty good. That'll be good enough for government work. We'll be fine there. So our do fire over here, we're going to go ahead and do a little bit of a change. The angle is fine. These angles are totally okay because they're relative to feet. We're just figuring out about our angle and stuff. But the actual shot, we're going to go ahead and say that we're going to shoot from our feet plus new vector 3, 0, 1.5 f, 0. So the relative direction of our shot is going to be perfectly fine. Yeah. Everything should be perfectly fine. We just need to make sure that our origin is up because everything else about our aim angles and everything is relative. It's relative to our feet, but even if we went to chest, it's the same exact angles. So our rotation will be the same. Our aim angle will be the same. We just need to make sure our shot comes out somewhere above foot level, just to make sure that we don't get, we hit a pebble along the way and screw up the shot in a really awkward way. So we're going to fire a weapon from basically chest level in the direction of firing, which is based on our aim angle and all that. So let's go ahead and find out if that's going to work. I will note at this point, if we go ahead and actually grab the bot controller, it's got a main camera component that we can get rid of. Oh, I guess I've got to drag it into the scene, get rid of that, apply the changes. I mean, it's deactivated, but there's no reason to have another game object kicking around there. So in theory, the bot might shoot us at this point. I suspect we'll have some errors. And by that, I mean, holy crap, that is one hell of a lethal bot. It is accurately shooting directly at me and murderizing me. Okay. All right. I was expecting that we might have a little bit of a thing there, but apparently we're okay. I'm going to reserve the idea that there might still be an issue in my aim angle. The Z, of course, will always be 1, and there's a little bit of a Y component depending on things. Okay, we might be all right. We might be all right. So, how do we make the bot less lethal? Because, honestly, this is a little bit crazy. So what we're going to do is we've got our targeting angle criteria. This is the angle at which we start firing. So the bots will start firing before we actually point towards the actual player, and that's okay. I think that's fine. But after that, ultimately the bot is going to turn, and actually right now it instantly turns to face the player. So this targeting angle criteria doesn't matter because we instantly turn to face the player. So one thing we could do is make the bot turn a little bit slower, and I'm certain we will do that no matter what. But the other thing we can do is add a little bit of noise to the firing direction. Just a tiny bit of extra inaccuracy to add some extra mischance to simulate basically like shaking of the mouse hand, which I would know very well. You know, giving a little bit of shake. The other thing you can do is when the bot is rotating to look at our target, right? Which is right over here. We are looking towards the target. What you could do is set up maybe a bit of an array or something like that where you track the position of your target over several frames. And so what you're doing is the bot will have a little bit of a reaction time thing where you're not looking where the player is now, you're looking where the player was, I don't know, 10 frames ago, like a fraction of a second, maybe one tenth of a second ago. So if the player is standing still, well then you'll be facing directly towards the player. But if the player starts moving, then there'll be a little bit of a lag. But then if they're moving in a straight line, the bot maybe should be able to predict where the player might go. And then you might introduce something like a PID controller, different things like that. We're going to leave that out of the tutorial, but those are terms to look up. Look up the PID controller. I think would be an excellent way to simulate that kind of a latency that a bot might have in aiming towards a moving character. And getting a straight up aim. For our purposes, what we're going to do is we're going to fake it. We're going to add some noise over here to make the bot slightly less accurate. So what we're going to do, we're going to add basically handshake to make the bot less accurate. So what we're going to do is we're going to put another variable at the top over here. So that's when we start shooting, float target inaccuracy. not even vaguely close to being spelled correctly. There's probably 2 C's. I'm just doing Google. That's my number one spell checker. Is I Google things. Yeah, a second C. Excellent. And we're gonna give him like 2 degrees of inaccuracy, which is going to mean short range, it's going to be pretty accurate. Long range is going to be much less so. This is, extra inaccuracy to simulate mouse hand shake or something. This could be tuned. You could have bots with different aiming skill. Again, if you do put in some sort of reaction time thing, then you can modify that based on how difficult the bots are supposed to be, and all kinds of fun like that. So over here, how do we do that? How do we add it in? Well, basically, we're going to take our fire direction, which right now is still in local space, but it doesn't matter. We can do it after it's global or before. It doesn't make any difference whatsoever. We're just going to add in. These are currently in Euler degrees. So we're going to add in something like a new vector. And in each angle, well, does it have to be each one? We don't technically need any roll, so we don't really need anything around the z-axis. It doesn't make much of a difference there. But left and right, which is the x-axis, and up and down, which is the y-axis, we're going to add in a little bit of noise there. And what we're going to do is we're going to say random.range from negative target accuracy to positive target accuracy. So right now, this will be a number from -2 to +2. And because these are floats, it will be sort of inclusive. So most likely it'll end up with a value of like -1.3587 degrees, comma, and then the same exact thing in the y coordinate, like so. And then because roll doesn't matter, I mean, we could add in a number there, but literally would make no difference whatsoever. Yes. Yeah, that is true. Okay. I'm really not lying, right? So now we're going to get a slight inaccuracy. And to make it super obvious, let me go ahead and set this to like 20 degrees of inaccuracy. So this won't affect how the bot is actually facing. It'll just make their weapons shoot a little bit crooked. Oh, the effect is really hard to see from this point of view. Let me go ahead and switch to the top. Our little line effect is not fantastic. Are they? That's really kind of wonky, don't you think? It looks like they're shooting backwards more than anything else. Oh, right. Right, okay, my bad. Because here, what we're doing is fire direction is not angles. It's an actual direction. So by adding these numbers in, it's crazy sauce. That's not what we want at all. What we want to do... Okay. What we want to do is grab this and put into something like vector 3 inaccuracy angle. Inac angle. So these are Euler angles. So then what we want to do is when we're doing our rotation based on our aim angle, we're going to multiply things by a second quaternion dot Euler based on inac angles. Or actually, hold on. I think it might be a little bit better if we say something like fire direction instead of plus equal. It's actually is the quaternion dot Euler of the inaccuracy angles multiplied by its current place. So now we've got something red because what? What is the error? An expected symbol new. Times. There we go. So now it should correctly be 20 degrees off instead of like a really wacky numbers off. There we go. And you can see he's having a really hard time hitting. Every now and again goes in a completely weird direction. Oh, I think it might be shooting through the floor at that point. Is that possible? I may have still not done it correctly. I mean, 20 degrees is pretty ridiculous. We might be okay. I'm gonna stop goofing around in there, and at some point we're gonna stop the tutorial. It's possible that I'll discover that there's an error in here, which I will correct maybe in a future episode. Yeah, okay, no, there's a glitch. Every now and again they're facing completely backwards. Why is that? Where do we put the debug in here? We're debugging after we put in the inaccuracy. And we're ending up with numbers that seem... They seem reasonable. They tend to aim down. Huh. Just out of curiosity, if I remove the randomness along the y-axis, would that lead to something better? I'm still not convinced our aim angle stuff is quite correct. Actually, a good way to test that then would be if I were uphill. I might have to make myself invulnerable here for a second. If I were uphill, does it still look okay? No. He's always aiming down. Look at that. Can't shoot me right now. Invert the aim angle. I don't know if that's correct. Okay, well, it is correctly, and then if I throw myself off the edge, it should go to a big negative y, if I can get there. Okay, player. I gotta change my health. Player health. 1 million. So if I'm uphill, he's correctly shooting up. Again, we won't see the beam effect correctly. Oh, no, sometimes they aim too high. Okay. These all look fine, though. Why does the shot ever go straight up like that? Oh, I bet you it's colliding against itself or something like that. That's most likely it. Something in the raycast and the fire weapon is probably... there's probably an error in the fire weapon code. Now, let's go ahead and throw ourselves off the cliff, and we should start to see some big negative Ys. And indeed we do. He's correctly shooting straight down. It feels to me that our inaccuracy code is correct. I think the problem is in the fire weapon code, something with the raycasts. I suspect very strongly there's an issue in there. Oh, maybe because we're firing within our body. Let's go ahead and start the raycast. And this is definitely sort of a hackish kind of fix. We'll start the raycast 1 unit in front of us. I bet you it's that sort of thing. We're probably hitting ourselves with the raycast, and then it's causing the angle to look really, really bizarre at times. So if I do something like this, do we get more reliable? Nope. We should be shooting up. Oh, but this is in world coordinates. Transform position plus transform dot up times 1.5 f plus transform dot forward. Just one coordinate. Tell you what, we'll multiply it by 2 to give ourselves. So we're going to fire from 2 units in front of us, and then we'll dial it back in a second here. Which also means we'll have to adjust the origin. Damn! Something is still not good. So I'm going to have to go ahead and make some adjustments between the scenes. If you download this project, it will have the fixes, and then I'll try to talk about them in the next video, because something is definitely off. But we're okay, right? We can shoot okay? Everything is pretty accurate based on how we want the shots to happen in our cells. Indeed they are. So something about the coordinates I'm feeding into that code is just off. And the problem is, my ability to piece out some math stuff from time to time is quite poor. So I apologize for that, but that'll bring us to the end of the bot tutorial in general. This was to sort of showcase how the bots can work and some various concepts there. For the next episode, what I'm going to do is I'm going to pull out the automatic bot spawning and get it out of the way. And we're going to start on power-ups relatively, well, hopefully soon. Hopefully it won't be another big pause, but I can't guarantee things. I've got a big schedule, and I need to fit in another 2D tutorial relatively soon. So hopefully the next part in this will be relatively quick, and we'll definitely be doing pop-ups. I know a lot of people still want a better user interface and GUI. I'm waiting for Unity 4.6 to officially come out. It's in beta right now, and they have release candidates, but it's not quite out yet. And then we'll at some point we'll look at a proper interface, but not quite yet. See you next time, folks. Bye-bye.